Well, it's progress. Lumpy progress, but progress. Hey guys, welcome back to the Porthole Party. Going to be working more on the Aldrich 16-inch set in this installment. When we left off, we did the first power-up and got a raster and some indications of life out of the tuner and a little bit of hiss out of the speaker. But I had to cut things short because a couple of the caps were getting warm. In fact, the main one on the power supply was getting downright hot. So, I'm working on replacing them. Now this one was mounted on a phenolic insulating wafer. Let me flip this over and talk a little bit more about what's going on. One thing I found kind of curious about this is the old filter cap, which is quite light, by the way, so I suspect most of the electrolyte is dried out. It's mounted on an insulated phenolic wafer. And on the end of the cable that plugs into the main chassis, we have this black lead with an eyelet that gets screwed right to this chassis. Well, check out the schematic. So here is that multi-section cap, C38. And these long lines here are the negative, the common negative on all four sections. It's coming off and going down to that lug, which simply gets connected to the ground on this chassis. So it doesn't need to be insulated from this. It is a grounded cap, but they chose not to connect the common negative to this chassis, but it does connect to this chassis. My best guess as to why they did that was something to do with hum from the power transformer. I don't know. It seems a little weird to me. Now that filter cap is for the output, audio output. We've got a cathode bypass cap, and the other two forming a pi filter with this bleeder resistor network going to the 5U4, and there's a main filter cap. So these three sections are power supply filters, and one is for the audio amp. But notice the 5Y3 has no filter. It just goes straight to pin 3 on the main chassis, meaning the filter caps for the lower B plus rail are going to be up here. Now there is another filter cap that's getting warm up here. So here's that pin 3. It's the 187 volt bus versus 360 for the one coming off the 5U4. So here's the filter cap for that. Looks like it's spread out between three different caps, I think, but not necessarily. Zenith's part numbering system can be a little goofy, but it's possible there are three different electrolytic caps up here, because there are three of them. 1, 2, 3. Seems a little weird that they would spread out the three filter caps across three different capacitors instead of using three sections in one cap, but that might be what they did. Well, one of these is also getting warm, the one in the middle. So it's going to be one of these three is also getting warm. Not as warm, but I think I should tackle that one as well before I try powering this up. Now, I did use an adapter cap for this guy because it was already on a phenolic wafer, so all the mounting holes in there are already lined up. But one thing I wanted to mention, if you're going to try using these adapter caps or something similar, is you don't have to undo all the wires going to the eyelets, component leads going to the eyelets, and put them into the little holes on the circuit board underneath. What you can do is leave all the wiring intact, component leads intact, and cut off the lugs and load up the solder pads on this, which are pretty generous, and simply push this down into it. So here's one of the lugs I clipped off the cap. This will all take solder nicely. So load this up with solder, load up that pad with solder, and then just push it down into it, and you can leave them sticking up. So now it's been one of the complaints about using these is people like having those lugs sticking up with the eyelets to put component leads into. Now I could have been more aggressive and cut them down even lower on this. You could also buy eyelets and again load them up with solder and push them down into those pads and then feed your leads into. Just, giving you some suggestions or thoughts on how to do this. On this one, it's going to work out especially nice. For example, here's one of the lugs with two wires going to it. and I oriented the new one exactly the same as the old, so I simply have to put a little solder on this and push it down and I'm done. So very, very quick and easy. Don't have to disturb any original wiring, don't have to desolder anything or unwrap any leads. Just heat, tin, push down. I think while I got this up, I'll also tackle replacing this. Now this is still good. This guy was open, this guy was still good, but looked very toasted. So I put in new resistors that are about double or more the original wattage rating. But I left this guy in. I did buy a beefy 25 watt chassis mount replacement for it. So while I'm down under here, I might as well drill out these rivets, remove this. Because these are not the most reliable things. As we saw, the one over here is open. In fact, I suggest if you're working on a Zenith porthole set, and in general anything this old, replace all the power resistors. They tend to form corrosion and go open. I don't necessarily think it's corroded, say, in the middle here. I think the corrosion happens near the ends where the leads wrap around these lugs, but you really... These aren't serviceable, so I wouldn't even bother messing with it. You want to leave it there for appearance, great. Mount the new one over here or something, but I'm going to replace that while I'm under here. And as always, I'll take some CLR and wipe down the chassis to get rid of all the lovely greenish cadmium corrosion. I've finished wiring the new caps, got it hooked up to the chassis again. Let's try power up and see what difference some new caps make. Remember, we only had deflection about that high before and no reception. Okay, well, so there's one big difference. It's almost filling the screen now. So let's check the switch down below here. Alright, so normal mode, expando mode. So, alright, we got that. Now let's see if we can actually get anything on the screen. So, got contrast wide open. No. So, not much of anything. Oh. I wonder, is the tuner just dirty? So as I'm turning it. Although, that's got to be a radio station I'm picking up, FM radio. Because I'm feeding a signal that there shouldn't be any sound. Or there should just be a tone, rather. I don't have any programming being fed in, which is a test pattern. So... So what's happening is it's making partial contacts and it's tuning off frequency. But we could have some dirty contacts and that's when they land on the channel. It's not coming in. Oh yeah, so I get static when I go between channels. But when I clunk into the channel, it's gone. Ah, and that was my test pattern for a moment. Here's my test tone. Yeah, as the sound fades out, you can see the test pattern for a moment. Okay, well, I guess we're going into the tuner, which is this monstrosity. Oy, how do you even clean the contacts? Well, it's this way, which is another chassis I've worked on. You take this cover off. I guess you still can't even know what's on its side. So 2 on that side, 2 on that side. And let's see if there's something to clean in there. And then right after this, I'm going to go through and check the tubes because I haven't done that yet. Just got the 4 screws out, and yeah, this just comes right off, which reveals the sort of Ferris wheel tuner. So similar to the standard tuner that many other sets used, just on a much larger scale. By that I mean each one of these phenolic wafers is a channel, and you can remove these, you can replace them. I think they claimed in the advertising you could go to UHF with this because it was so well designed it could handle the higher frequencies, and you wouldn't need an external UHF to VHF converter. Alright, so these little tabs sticking up are going to the components inside, and they make contact up there. So yeah, not so obvious how to clean them. Hey, then there's numbers on them too. Good. So that's 2, because I don't need to clean all of them, just the one I'm trying to work with now. You can see it's got some dirt in there, so that's 5. So let's see, I'm trying to figure out how I can tell when things are engaged. So if that's 5 there, turn it up. Now it's engaged, so 5 is here. So if I'm reading this right, whatever number is in this position is what's currently tuned in. Basically where this light bulb is pointing to. Alright, so yeah, and I got that on 5 too. So let's focus on cleaning 5. Bring it down, that's this guy. So I'm going to get a Q-tip and some deoxit and put it on these points. I would like to get up in there too, but it looks like I would have to take the drum out or remove this to really get in there. I'm not just going to shoot contact cleaner in there if I don't have to, but I guess that's another option too. Also, I'm going to lube this puppy because it's a little stiff. Oh yeah, so there's the giant roller. It's behind here. So this metal plate is springy steel. It's screwed down in 2 points, and there's a roller wheel here that runs up against these. So we want to lube that up and hit up these gears too. It's crazy how big this ridiculous tuner is. I finished testing the tubes and the tuner and the IF, and here's what I found. First off, something odd. 6C4 tube, which is used for the local oscillator. It's kind of the shield. Got 0 emissions on my Hickok 800, so I tried Hickok 600, same thing. Pulled out a new old stock one, also 0 emissions. Now it seems really odd to me that a very popular tube tester could go through several incarnations with the wrong settings in the setup charts for a relatively common tube, but maybe that's the case. So anyways, I got the new old stock one in there. One of the 6 CB6s, which is these 2 guys here, was bad. Also, no emissions, although the filament lit up, so that got replaced, and I tested the tube before I put it in, and these both have good emissions, no shorts, no leakage. Let me get down into the IF. We had 1 weak 6AU6. This has 4 IF stages, all with 6AU6s, so I replaced the weak one. Now we have a 12AT7. Half of it's used for sound, the other half is a noise limiter, kind of part of the AGC chain. That got replaced, and then finally the 12AU7 video amp was weak, and that got replaced. So here we go. Power it up. Let's see if it makes any difference. 6C4, I believe, can operate at pretty high frequencies, and I believe when I saw an original Zenith ad, they claimed that when UHF comes online, you could just replace one of these tuner sections, and the oscillator could operate at that higher frequency. Alright. So let's back up. And the reception now. Yeah, everything's plugged in. So still just between stations, but it seems stronger now. But I just can't find a place with the tuner where I can hold the shaft and get the reception. Also, I wonder if it's possible that the problem was just AGC all along, and everything is working right, but it's killing the gain because something isn't right. And so when I go off station and come back on, so typically the AGC has a capacitor, usually kind of large, maybe even as much as a microfarad, and that sort of averages the signal strength coming in and produces a bias voltage. If that circuit's screwed up, I can see why when I'm off station and then come on, you get it briefly as it comes in, then it cuts out as that cap charges up. It's my best guess as to what's happening right now. Or it's still flaky tuner connections. Which means it's very likely that original 6C4 was just fine. Turning it really slow. Now, in fact, usually if I turn it slow, it's even worse. Kind of confirming my theory that it's a capacitor charging up or leaking away charge. Oh, that's annoying. Alrighty, well, I think we're going to require a little more investigation. Worst case scenario, we have to go into the tuner. Now, let's do a little signal injection right now to eliminate that, and let's inject a video signal right into the grid of the video amp. I suspect that will get us a nice strong image. To do that, I'll have to tip this thing on its side. So, metal cone CRT, yes, it's at a very nice high voltage. But we got this insulating ring, so it should be okay if I lay this on its side on the workbench. And if you need any proof that there's still a charge on that cone, well, let's see if I can show you that. Let's take a long bladed screwdriver, ground, and a little bit of a spark. Most of it bleeds away when you turn it off, but there's a little bit of a residual charge. So you want to be careful even if you turn the set off and wait a few minutes, there's still going to be a little bit of a charge there. Not much. It'd be like walking across a rug and touching a doorknob and getting a little static shock, but it would be there. 12AU7 video amp is way here at the back of the chassis, where that contrast control comes in. Just hooked up my test lead to pin 2, which is the grid of the first amp. And guess what I discovered? There's a cap hiding back there. 0.047 microfarad coupling cap to the grid of that video amp. I missed it when I was recapping this. Would not be surprised at all if that takes care of our problem. But before we do that, let's try it as is. Turn on the power source. And here we go. You're doing this when you're feeding in signals and you have test leads. Make sure none of them go anywhere near that. The insulation in your test leads is very unlikely to be able to withstand 10,000 plus volts. Well, that's something different now, isn't it? Just the TVA92 output here. Carefully, I don't know if I should go positive or negative. Looks like I was going the wrong way, maybe. Alright, so let's see, controls. Here's horizontal hold. Ooh, we get horizontal hold. And vertical hold. There's one right next to it. And look at that. Boy, do we have some crappy linearity. Just doesn't surprise me because I haven't replaced the electrolytics on the video amp yet. There's a little bit of trouble locking. Let's get rid of that buzz. The contrast up. Just the brightness. Looks pretty good and a bit trippy. Let's try to adjust the linearity a little bit. Almost. Let's play around with the amplitude of what I'm feeding in. Too strong, gets washed out. Let's back off. Well, it's progress. Lumpy progress, but progress. Alrighty, I replaced that cap. You can just barely see it back there. And now I can just eke out an image. So we got serious lack of gain, but something is getting through. So I think the tuner contacts are okay, but we've got problems. It could just be we got bad resistors and bias or plate voltages are way off. But I don't think I should really go too nuts with troubleshooting until I replace the electrolytics down here. Should resolve the vertical height linearity issues, and as I keep saying, we got power supply issues. There's really not much point in troubleshooting. I also got a few more tubes to check, so I didn't check the octals yet. But I also thought you guys might be interested in knowing what's inside that tuner, so I popped out one of the strips. And this is what you get. So there's an adjustable coil up front, and that's what this is all about. So there's a hole cut out. See all these holes here? You use this to make fine adjustments to the local oscillator, which is what that slug is for, which is delightful because it's close to the bell, the CRT, which is at full high voltage. So exercise caution when you make that adjustment. And we can now peer down inside, and you can see all the other channel strips down in there. So that's cool. Alrighty, so I will continue troubleshooting, and yeah, I mean, when you get to this point where you can turn the set on, we're getting a raster, we're getting kind of an image. Now it's time to just knuckle down and go through and do the troubleshooting. Get out the voltage chart, resistance chart, and start going through the pins on all the tubes. Do the video amp and start going back. There's an awful lot of resistors to check. Found a bunch of bad ones down in the horizontal. I've spot checked a few as I was replacing caps and didn't find any that seemed way off, but there's still plenty I didn't check. And yeah, of course, these three electrolytics, which I've been avoiding doing yet because it's not much fun. Now that one's not so bad. It's on a phenolic wafer. It's near the back side. Probably use an adapter cap for that. But these two are twist locks. But more importantly, they're located underneath the support tower for the CRT. So I know one technique that's popular with some guys is to cut them open in place. Leave all the wiring intact, get in there with a jeweler's saw, pipe cut or whatever, and cut them open, drill holes, feed the new cap leads in. You can't do that. Not without unmounting the picture tube and the entire support bracket and the yoke of the focus coil and all that stuff. So, couple options. One, disconnect everything under the twist locks, pop them out, either rebuild it or use an adapter cap or whatever, and buy new caps with you can get twist locks from one or two makers out there anyways, or install a new one from the top side, or disconnect everything, install a terminal strip and mount new caps down below. Haven't completely decided yet, but yeah, they need to go. Before I dive into replacing those electrolytics, though, I do want to lube the tuner because I already broke the fine-tuning string on one other set because it was so stiff. So I've been going through and hitting up the gears, the bearing points, this guy especially in the back, that roller there it actually has some ball bearings in there. It was bone dry, so it it is considerably nicer to turn now. I thought while I was at it, I'd take a look in here because I want to lube up this pulley, and I can't. It's going to something in here, so I just took out the 4 screws, and of course we're going to take all the necessary precautions. I discharged this CRT again, so let's take a peek underneath the hood of the tuner here. Gets a little bit hung up on the other side because there's some adjustments sticking out. There we go. And don't recommend you go mucking around inside tuners because they tend to be fiendishly complicated, not electrically so much as mechanically, because every little position of every component will affect the capacitance and the inductance, and when you're working at hundreds of megahertz, everything matters. So here's where the fine tuning goes. Well, not much to lube, it's just I think this is I was going to say phenolic, but it's not even quite that, but it's like fiber with resin embedded in it. In other words, it's non-conductive. I got a wire for tension. Geez, it's probably been wearing into that for the decades. Oh, hang on. That doesn't look right. I think this was a power resistor, but it's not no more. Well, that could be causing a problem. What do you think? Alright, so I'm going to dive into the SAMs and find out what that is. Now, yes, I know what I just said about moving things, but a resistor like that is probably a plate resistor or something. That's not going to matter so much. But like these guys, coils, yeah, we're not going to mess with any of that. So let's see, how does this fine tuning actually work? Looks like those are eccentric things there on the shaft. Oh, is that all they do? Oh, wow, that's trippy. So, I presume these 2 bent pieces of metal here on either side of that are feeding a signal through, and just the eccentric discs here form a capacitor. There's no electrical connection to these 2. That could be affecting either the coupling of an inductor or a capacitor capacitance. That's how the fine tuning works. And you can see that when I do this, how that string flexes. That's not good. But yeah, let's take care of that guy. I think we might have found our smoking gun. Kind of amazed the signal's getting through at all. It's probably bypassing a stage completely, and it's just because the gain is so wide open, it's just leaking through here. Before I get to that resistor, I just put a little bit of this Lubra plate grease number 105 on those bearing points there and there, and boy, what a difference that made. I can rest easy on that. So I always tell people, don't go into the tuner unless you absolutely have to, but I gotta say, if you have one of these sets, you should get in there and lube that up, because these get really stiff, and this dial string is ancient and very likely to snap. So, and also the channel clunker makes a huge difference if you lubricate that. Alright, let's get that resistor replaced. Well, replacing that resistor allowed me to get a signal passing through the tuner. It's not great though. This is with a contrast. In other words, the gain up all the way, the signal to noise ratio is not great. I'm feeding in a really strong, clean signal. Should be a lot better than this. So, troubleshooting will continue.